Hi, this is Priyadharshini, working as an assistant professor in the Department of Artificial Intelligence and Data Science. In the previous lecture, we have seen what is an algorithm and the analysis of algorithm. Here in this lecture, we are going to see what is an asymptotic notations. As we all know, asymptotic notations, it is nothing but it is a mathematical way to represent the time complexity of an algorithm. In asymptotic notations, we have three different kinds: big O notation, omega notation and theta notation. So let's see in brief what is big O, theta and omega notations. So big O notation. So it is asymptotically lesser than. So if there is a function f of n, it is always less than or equal to a function g of n. Then omega notation is asymptotically greater than, that is f of n is always greater than or equal to g of n. Then that theta notation, so it is asymptotically equal, that is f of n is always, a function f of n is always equal to a function g of n. So let's discuss in brief what is big O notation. So big O notation is, it is the maximum time notation will be given in terms of big O. So what is big O? We have a graph basically here. N is what? Input values, and we have in y-axis it is time. Now to understand this, we have a function f of n. So f of n, if I have any problem I have to solve. Let's say my time is small, my function is f of n. Now if I have to write f of n in terms, let's say order of g of n, what does this mean? That is, g of n will always be greater than c into g of n, like this. C into g of n means f of n is given to us, and if you have to represent this in terms of big O, so here g of n should always be greater than or equal to c into g of n. And here c is a constant term which should always be greater than 0, and the value of n, this input value we are taking, this n should be greater than or equal to k, and you can say k should be greater than equal to what? It should be always greater than or equal to 0. We are talking about the k. So here f of n is equal to order of g of n. F of n is always less than equal to c into g of n. So here if we discuss this in an example, then it will be more clear for you. Let's say I have a problem, any algorithm. To solve it, the total time I took was 2n square plus n. So the total time, that is f of n, is equal to 2n square plus n. Now if I have to represent f of n in terms of order of notation, means f of s is equal to order of what? F of n is equal to 2n square plus n. F of n, remember f of n is 2n square 1, and it should always be less than or equal to c into g of n, and g of n, that n value you have to choose. Now obviously this function should be greater than. To make it greater means that equal to upper bound. Bigger notation represents upper bound. Bigger notation always represents upper bound. This is called at most. Means in doing any work, maximum time you will take, that is big O notation. Now here upper bound means which is the bigger term from 2n square plus n. Now we have to find the bigger term. Obviously you have to do higher, you have to check n is n square 2. What is n square? It is a quadratic function. And here if we talk n, that is linear equation. Now which will be dominating in quadratic and linear? Obviously n square will be dominating. How? If you put the value of n this way, if we put the value of n as 100, then it is 100. Now how much time will be n square? It will be 10,000. If you put the value of n as 1 crore, obviously n is 1 crore, and n square will be 1 crore power 2. So the value of n square is always bigger than n. If you want to represent it also, we can represent in the way. So n is linear time. What about n square? N square will obviously grow more than n. But now for n for the small values, because if you put the value of n as 1 or 0, then you are not getting much difference. But for larger values, which is dominating? N square. So here if I want to write upper bound, means if I want to write a big value, then can I write n square, n cube, or n power 4, n power 5, n power n. So 2 power n, all these are bigger than the term. But remember, whenever we talk about upper bound, always remember least upper bound means we have to choose only the closest value. We have to choose only the closest value. So what is closest here? N square. So this point is representing here because 2n square plus n should always be less than or equal to c into g of n square. So you have to choose c value here. To take c value, obviously if you take c value as 2, if you take c value as 2, then it will become 2n square plus n should be 2n square plus n. But if because your plus n is also there, so what you take? C value. We take c value as 3. So if I take c value as 3, if you solve this, then what will happen? N is less than equal to 2n square. If I divide both sides with n, it will be 1 less than n, which when you write n should be greater than equal to 1, means for all values of n, for all values of inputs n greater than or equal to 1, this condition always hold and the c value should be 3. So here I have c value 3, and for n greater than equal to 1, this condition will always hold, means 2n square plus n can be written as order of n square. But what should be the c value? It should be 3, and for the n values greater than or equal, this condition will hold. So this way we represent big O notation. So if my f of n is increasing, if I want to write big O of g of n, so g of n means you have to write upper bound. So let's see the definition. So for a function f of n is equal to big O of g of n, there exists a positive constant c and n naught such that 0 is less than f of n, which is less than or equal to c into g of n for all n greater than or equal to n naught. If f of n is big O of n squared, then f of n can be larger than n squared sometimes. But if I choose some constant c and some value n naught such that for every value of n larger than n naught, f of n is less than c into n squared. That is, for values larger than n naught, f of n is never more than a constant multiplier greater than n squared. So this is about big O.